In 1968, Wason developed a different way of looking at human reasoning because he was really interested in investigating how people assess claims, conditional claims, and how do they assess rules and understand rules. So the task goes as follows. Um, you are given a rule, which you see right here, and I'll read it in a second, and then you're given 4 cards. And in this particular version, each card has a letter on one side and and a number on the other side. So of course here you're seeing only one face of each of these 4 cards. So the rule says if there is a vowel on one side, there has to be an even number on the other side. And your task is to pick the cards that help you determine if the rule is true or not. Okay, so your job is to pick one or more of these cards that help you determine if this rule is true given these cards or not. Which cards would you pick? Which cards would allow you to verify whether the stated rule is true or not? And if you don't want to know, pause. Now, most people typically choose the very first card, the E. Of course, it makes complete sense. Why? Well, because if there's an E right here, so if there's a vowel, and I turn it, I'd better find an even number. Because if I don't find an even number, then the rule cannot be true. And this, if you think of it, is nothing but a modus ponens. So definitely you want to pick the first card. In fact, I want to guess that most people have picked the first card. My other guess is that you've also picked card number 4. This one, well, the card, sorry, that has the number 4 on it. Okay, we'll get to it in just a second. All right, let's look at the second card. So this card has a K on it. What happens if I turn it? I don't know. The rule doesn't say anything about what happens if there's a consonant. Maybe there's an even number on the other side, maybe not. I have no idea. The rule just doesn't say anything. So picking this card, picking the K and turning it does not allow me to do anything about this rule. And if you think of it, this is nothing but denying the antecedent, right? If instead of a vowel, if I say not a vowel, but I have a consonant, can I make an inference from this rule? No, right? Because denying the inference, as you remember, is an invalid, denying the antecedent is an invalid deduction. So turning the second card doesn't help me. What about the third card? And as I said, most people tend to choose the first and the third. Well, let's see. So here I have a 4. If I turn it, what should I see? Well, see, you're tempted to say, and if you've picked it, it's because you say, well, if there's a 4, I got to have a vowel on the other side. But that's not what the rule says. The rule says if there's a vowel, well, there better be an even number. It doesn't say that the vowel is the only way. It doesn't say that the even number is there if and only if there is a vowel. It says if you see a vowel, then you'd better see an even number. But it doesn't say that I can't get an even number in any other way. And if you think of it, this is nothing but affirming the consequent, which is also an invalid inference, right? If I affirm the consequent of an if-then statement, I can't conclude anything. So turning the third card that has the 4 on it doesn't help you verify if the rule is true or not. What you should do is you should turn the first one and the last one. Well, think of it. Here we have a 7. If I turn it, what should I see? Well, I don't know, but I'd better not see a vowel. Why? Well, because if I see a vowel, there should have been an even number. So if I see a vowel, this confirms the rule. That says that the rule is false. So turning this card is very helpful. Because if I turn this card and I see a vowel, then the rule is wrong. Much like if I turn the first card and I don't see an even number, the rule has to be wrong. Then if I turn the last one and I do see a vowel, then the rule is wrong. Why? Well, because if I see a vowel, I should have had an even number on the back. Instead, I have an odd number. You'll remember that this is our good friend, the modus tollens, which is a valid inference. Now, if you picked E and 4, as most people do, don't be upset. Just about 4% of the people usually pick the correct. And this task is important for two reasons. First, it is a wonderful example of a very profound tendency of the human mind, which is known as confirmation bias. We just seem to have a spontaneous tendency to seek out information that confirms what we know or that confirms a rule rather than disconfirming. That's why you picked the 4, because that is a way to try to confirm the rule. Instead, you should have tried to falsify it by picking the card that had the 7. In a sense, this just seems to show that we have a spontaneous tendency to seek out confirmation of premises, confirmations of rules, rather than information that disconfirms it. And this is a very profound aspect of the human mind. In this particular case, it led you to turn a card that did you no good, number 4, when you should have picked a card that allowed you to falsify it. But more generally, it's just a very powerful tendency that leads us to always seek for information that confirms what we already know, what we think, what we believe. Now, the second reason why this task, the Wesen task is important, is connected to the following. So similar problem, similar setup, similar task, just different rule, okay? So in this case, the rule is if a person is drinking alcohol, they must be 21-year-old, or at least 21-year-old. And here we have 4 cards. Now, each card has a drink on one side, which is either a beer or a soda, is either alcoholic or non-alcoholic, and then has an age, on the age of a person on the other side. Which 2 cards would you turn in order to verify if the rule is true, meaning if the rule, is upheld and nobody's breaking it? Which 2 would you turn? Just like before, if you don't want me to tell you, pause. Now, earlier, most people picked beer, right, the first card, and the third card, 24-year-old. I want to bet that now most people picked beer, but picked 16-year-old, the last one, and you'd be correct. Let's see why. Well, again, the first one, beer, makes total sense. It's a modus ponens. Look, there's beer on this side, so if someone's drinking beer, they'd better be 21 or older. So I definitely want to turn the card beer. But the card soda, should I turn it? It doesn't do anything for me, right? This is a denial of the antecedent. So this says if someone's drinking alcohol, then they must be 21-year-old. But if they're drinking soda, I don't know, they could be 21-year-old or older, they could be younger. The rule just doesn't say anything about that. How about the third one? This is the one that earlier everybody chose, or people tend to choose more often. So someone is 24-year-old. Should I turn this card? No, it doesn't do anything for me. They could be drinking alcohol. They could not be drinking alcohol. It doesn't bear on this rule. Indeed, this is an affirmation of the consequent, which, as we said earlier, is an invalid deduction. Like before, what you want to turn is the modus tollens card. This should have been MT, modus tollens. Because if someone is 16-year-old and they turn the card, they'd better be drinking soda, right? Because if they were drinking alcohol, they should have been at least 21, blah, 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 blah. And see, what is so powerful is that when the exact same problem as before is couched in this type of social norm, in the social content, suddenly 73% of participants now choose the right card. We went from 4% to 73%. And from a logic standpoint, it's exactly the same problem as before. Yet, somehow, given a content, we suddenly become very good at doing logic. We suddenly become extremely logical. And so this clearly shows, which is the second important point of this task, that just people seem to perform logical reasoning just much more efficiently when they're dealing with sort of concrete, real world type examples, similar to the type of problems we engage in all the time. And one of the theories as to why it is that suddenly the same logic problem as before becomes really easy when it has certain types of contents. One theory is that we just engage all the time with these sort of permission and obligation type situations. And so just throughout development, we grow to develop schemas that just we can then pull from in order to solve this problem. It's just something that we do all the time. We have to deal with permissions and obligations all the time. So we just become very good at it because it's something that we have to learn and use very often. There also is a second theory that says that it's actually more profound than that. It says that because we're a social species, we might have developed, and this is through evolutionary times, we might have developed a unique ability, in fact, a special module in our mind that allows us to easily detect violation of social norms. And that, of course, is something very important when cooperation and sort of abiding by social norms is so important as a species for survival. Either way, it is very clear that these heuristic effects, like the belief bias, the atmosphere heuristic, confirmation bias, and these content effects are clearly very powerful indications that absolutely we are able to perform those type of abstract deductions that we've seen at the beginning of this lecture. But certainly when we perform deductions, there just is much more than just that plays into how we understand and perform deductive reasoning.